Hello grade 12s and welcome back to another video. If you have watched all of the other videos and have now made it to question number 8, you can be incredibly proud of yourself. I hope that all of your efforts will pay off. We are looking at question number 8 of the November 2021 Physical Science Paper 2 exam, and this question deals with galvanic cells. This is electrochemistry. And in a galvanic cell, we have a spontaneous reaction and chemical energy is converted into electrical energy. Now, in this section, these three equations are relevant, and these equations help us to calculate the cell potential of the specific cell that we are dealing with. Another name for cell potential is the potential difference of the cell. And from the section on electric circuits, I'm sure that you all know exactly what potential difference is. So there are three different versions of exactly the same formula. You just choose the one that you understand best. We are subtracting or finding the difference between the cell potentials, the half cell potentials. We can say it is the cathode half cell minus the anode half cell's potential. Or we can say the half cell where reduction takes place minus that where oxidation takes place. Or that where the oxidizing agent is present minus that where the reducing agent is present. We are finding the difference between the half cells. That means that we are subtracting the half cell potentials. Also very important in this section is your table of standard reduction potentials. I will be making use of table 4a in this video, but of course you all know that there is also table 4b that will be provided in your exam. You choose the table that you would like to work with, and I suggest that you stick with that table from the word go and decide to master that table. Don't be confused with the other one. So I often advise my learners to cross out table 4b as soon as they get into their chemistry exam, so that they don't accidentally look at table 4b and come to conclusions based on it, because they are so familiar with table 4a. When we look at table 4a, we see on the left-hand side, it says increasing strength of oxidizing agents. That means that at the top we have strong oxidizing agents, and we therefore have the reduction half reactions at the top. Reduction is going to take place in this direction because reduction is the gain of electrons. If we look on the right-hand side of the table, we see increasing strength of reducing agents as we go down the table. That means that those half reactions towards the bottom normally represent the oxidation, not reduction, but the oxidation half reaction. Remember, oxidation is the loss of electrons, and therefore these half reactions will be written out in that direction, or we'll choose the reactions that take place from right to left according to this table. We see that towards the bottom, the half cell potentials are very negative on this table, and as we move up towards the top, the half cell potentials are more positive. Half cell potentials and cell potential is measured in volts, because remember, cell potential is just potential difference. Question 8 now says, the table below shows two half cells, A and B, used to assemble an electrochemical cell under standard conditions. If it's going to make it easier for you to understand, then I do suggest that you go and draw yourself a diagram of what is going on. So draw a galvanic cell for yourself. As you can see, I have drawn a diagram for myself. It's not drawn very well, but at least it's going to help me to understand what is going on. We have half cell A, in which we have copper ions that are floating around in solution. The electrode is made up of copper solid. On the right hand side, we have half cell B, where silver ions, I've accidentally written Ag2+, but this is actually Ag+, so there's no 2. It just has a charge of +1. These ions are floating around in solution, and the electrode is made up of silver. I've included a salt bridge and on the outside a voltmeter to measure the cell potential for this galvanic cell. Question 8.1 now says, state the energy conversion that takes place in this cell. We know that a spontaneous chemical reaction takes place in the cell, and chemical energy is being converted into electrical energy. For writing this down, you obtain 1 mark. Question 8.2 says, calculate the mass of silver nitrate used to prepare 150 centimeters cubed of electrolyte solution in half cell B. We can see that we have been provided with the volume of the solution, but in order to determine mass, we're going to have to at least know the concentration of the solution as well. Remember that right at the beginning, they said that this cell is being assembled under standard conditions, and standard conditions means that the concentration is equal to 1,0 mole per decimeter cubed. So therefore we know that the concentration of this solution that we're going to be dealing with is going to equal to 1,0 mole per decimeter cubed, and we can now use that in a formula to find the mass. The formula that we use is one that we learned of in grade 10. C is equal to M divided by the molar mass multiplied by the volume. We plug into the place of concentration the 1 or 1,0. We don't know the mass, it is what we're trying to find. The molar mass of silver nitrite, sorry, not nitrite but nitrate, silver nitrate. The molar mass of silver nitrate is 170. The volume is given to us as 150 centimeters cubed, but we know that we need to substitute into this formula the volume in the correct SI unit. We would like to convert centimeters cubed to decimeters cubed, and to do so we divide by 1000, giving us a volume of 0,15 decimeters cubed. When we solve for the mass, we find that the mass is equal to 25,50 grams, and this is the answer to this question. Since this question is out of 4 marks, 1 mark will be awarded for the formula, 1 for the concentration of 1 mark for everything substituted at the bottom of the formula, and 1 mark for your final answer. You can of course calculate exactly the same answer using N equals C times V, and then the mass is equal to the number of moles times the molar mass. You can of course take a look at the marking guidelines to see if your method of using these formulae is correct. Question 8.3 says, define the term reducing agent, and you could choose from any one of the following definitions. We normally say that a reducing agent is a substance that loses or donates electrons, but you can also say that it is a substance that is oxidized, or you can say it is a substance whose oxidation number increases. In this case, you were allowed to pick from the various options because they just ask you to define a reducing agent. But if they ask you to define the reducing agent in terms of electrons, then you need to specifically mention the first option. And if they say you need to mention or define the reducing agent in terms of oxidation number, then it is compulsory that you choose the last option. But for any one of these in this specific question, you will obtain 2 marks. Question 8.4.2 says, write out the balanced equation for the reaction that takes place. We fortunately already highlighted the relevant half equations, and we can now write them out on the side. So we have silver, Ag plus silver ions, plus an electron, because they're going to be reduced, is going to form silver solid. The silver ions are in solution. If we are looking at copper, then we know we still write it out from left to right. So it will be the copper solid, this substance, is going to undergo oxidation and it will form copper 2 plus ions that will be dissolved in solution plus 2 electrons. Now that we have written out the half reactions, the reduction half reaction and the oxidation half reaction, we know that we need to balance or ensure that the electrons are equal. If we look at the oxidation half reaction, we see 2 electrons, but when we look at the reduction half reaction, we see only 1. The lowest common multiple of 1 and 2 is the number 2, so we're going to multiply everything in the reduction half reaction by 2. We therefore end up with this reduction half reaction, and now we can write out the final equation, which is going to be 2 silver plus ions is going to react, and we can indicate that this is in solution, is going to react with copper solid in order to form the 2Ag solid, right? So this is 2 moles of silver solid, plus we have 1 mole of copper 2 plus ions that are dissolved in solution. In the end, this is the final balanced equation. You're going to get 1 mark for all of the reactants being correct, 1 mark for all of the products being correct, and 1 mark for everything being balanced. That gets you your 3 marks for question 8.4.2. Question 8.5 says, calculate the initial EMF of the cell. So we are trying to calculate the cell potential. We always choose the formula, the one of these 3 formulae that we are most comfortable with. I find that I best understand the second version, so we're going to write that formula down. We've already identified the half cell where reduction takes place and the one where oxidation takes place. The half cell potential for the reduction half cell is positive 0,80, and that for the oxidation half cell is positive 0,34. So we're now going to subtract these 2 values. We say positive 0,80 minus positive 0,34. When we plug this into our calculators, we end up with a value of 0,46. This is the EMF, and it is measured in volts. In the end, this question is out of 4 marks, so you're going to obtain 1 mark for writing down the correct formula, 1 mark for selecting the correct half cell potential for the reduction half reaction, 1 mark for subtracting the the half cell potential for the oxidation half reaction, and then 1 mark for your final answer. For grade 12, you're only going to get this mark if you write down the correct SI unit. And for some reason, with questions like 8.5, learners always leave out the SI unit. So please don't leave out the SI unit. For writing this down, you're going to obtain your 4th mark, bringing us to the end of question 8.5. Question 8.6 says, how will the EMF of the cell be affected if the concentration of the copper ions in half cell A increases? Choose from increases, decreases, or remains the same. So over here, I have the diagram that I drew right at the beginning, and I would like to remind you that when this galvanic cell is in operation, what is going to happen is that the silver ions are going to migrate towards the electrode where they're going to be reduced. So silver ions are going to go out of solution. On the other hand, the copper solid is going to be oxidized, and we're going to have more and more copper 2 plus ions that are going to, in a sense, saturate the solution. Now, as this happens and more copper 2 plus ions are dissolved in the solution, what is going to happen is that the internal resistance of this galvanic cell is going to build up. And when internal resistance builds up, the EMF is going to decrease. So the answer to question 8.6 is decreases. And for writing this down, you're going to obtain 1 mark. In the end, question 8 is out of 16 marks. We've now reached the end of this question and this video. In the next video, we're going to be taking a look at question number 9, which is a continuation of the section on electrochemistry. But in question number 9, we're going to be dealing with electrolytic cells.